All right, let's see if we can't wrap up this factoring review with 2 more special cases. So more special cases. I mean, could you get any more special than the last case? Hard to say. It is legitimately hard to say. This is called difference of squares. And so the format here is something that looks like, so x squared minus, I'm trying to think of what variable to use here. I don't want to say c, because c is our normal one. Maybe I'll do d? X squared minus d squared? Sure. The idea is that this can become x minus d and x plus d. This is kind of generic. This is maybe not super obvious what we're getting at here. So as always, let's look at an example to try to see if we can't make sense of this. Now, this is just a special case. So if you see something like x squared minus 16, in theory, you can do the same exact factoring processes we've been doing, which is actually how we're going to start this. The idea here, right, is that, so if we kind of go through A, B, C, the idea here, the A is 1, so that's cool. That kind of uses our special case from before. The C value is obviously negative 16. And then the thing that's maybe a little bit less obvious is there is no middle term, right? The sort of B term here is missing, which means the B value is 0. So the real special case here is, well, 2 things. One, the most important thing is that this B value is 0. The second important thing is that something like 16 is a perfect square. 16 is, right, 4 times 4 is 4 squared. So this format, x squared minus some number squared, this is really x squared minus 4 squared. So in theory, what should be happening here? I'll do the fast version and then we'll sort of break it down. So if I just kind of go by what this says, so this is x squared minus 4 squared, right? 16 is 4 times 4. So in theory, this should be x minus 4 times x plus 4. And I say in theory, but in fact it is. Let's go through this in a little more detail to try to make sure we can believe it. You know, math isn't the kind of thing where we should just say, trust me. Let's actually try to justify this a little bit. So let's go through the steps based on, you know, A is 1, B is 0, C is negative 16. So let's go through the process. We can use our special case number 1, right? So the value for A is 1. So that's going to help us speed things along a little bit. That means I really need to just look at the B and the C. You know, I can either think of this as A times C, which is also just C, right, is negative 16. So I need to multiply to negative 16. And then my B value is 0. So I need to add to 0. And so what's key to making this special case work? Hey, Thomas? Oh, my God. Don't worry, everybody. The math is fine. The cats are fine. Love to have pets. Anyway, so what's important here is that you're going to add to 0. So the only way, right? The only way to sort of have that work is if you're going to add up positive and negative versions of the same number. They have to cancel each other out. So without really thinking too hard about this, the only way this makes sense is to use plus and minus 4, right? That's our only option. We don't even really need to check like 1 and 16 or like 2 and 8. It's extremely obvious that the only way to add to 0 is to have essentially positive and negative versions of the same number. They need to cancel each other out entirely. So that only works if you have a perfect square, right? Something like 4 times 4 to get you to 16. So if I have that, right, in theory, now what happens is, so in our rewrite, so x squared minus 16. So in some sense, what's happening here is we're saying this is x squared if we do the full, like, drawn out explosion kind of version. Negative 4x plus 4x minus 16. If I go through the full steps and like factor this down, right, this is sort of x comes out. This would be kind of 4 comes out. And so what's left over here, right, is x minus 4. If I do this is like plus 4, so then what's left over is x minus 4 on the inside. And so you can see what's going to happen when I factor it is I get x plus 4 from here, and then I get my x minus 4. Now, that's like the same terms in the opposite order as up here. That doesn't particularly matter, right? These are just multiplied together, so the order that we sort of end up with them is not something we need to really like watch and be careful about. It's totally fine. What this allows us to do is if I can kind of catch this pattern where I have no middle term and I have a perfect square on the end, I can do some very fast factoring. Let me give you guys some like super fast examples. So for instance, if I had x squared minus 25, right, the idea is of course 25 is 5 squared. So this is going to become, without even me really needing to run through all the steps, if I can recognize that pattern, I'm just going to jump right to x minus 5 and x plus 5. We can even get a little bit more creative if I throw some extra numbers on front. So not just x squared, but in this case like a 4x squared. We're kind of getting out of our a equals 1 territory. But if I do that, and this number is also a perfect square, right? So 4 would be 2 squared, and then my 9 is 3 squared. What happens is I can do not x and x, but I can do 2x and 2x, and then for the 9 I'm going to get plus 3 and minus 3. Again, you can always go through the full process here. That works and is totally fine. If you don't like catch this form and take this shortcut, that doesn't mean you're not going to get the right answer. You can always still get there using a slightly longer form. That's totally fine. So this is what we call the difference of squares. Difference, of course, because subtraction. Squares because squares, right? Perfect squares. Let's keep going. Our last special case, the least special case? Probably not. All cases are just as special as all other cases. So P5 review. So this will be special case number 3. And this is maybe the sort of least obvious one to pick out. What the form looks like, it's sort of an extension of the difference of squares. So you've got x squared, and you have a d squared. This is going to be a plus instead of a minus. And then the idea is that you either have sort of negative 2 times d times x, so a squared version of a number and then a doubled version of the number here. This is going to factor down as x minus d times x minus d, which you could sort of think of as x minus d like quantity squared. The other version is with a doubled version, but you're adding it instead, in which case you get x plus d and x plus d. These are obviously sort of three terms. These are sort of full quadratics with like an a and a b and a c as a part of it. Let me give you an example. So to a certain extent, it's, you know, maybe the least likely thing to catch. It's maybe slightly less obvious to catch than some of these other forms, which is fine. That doesn't necessarily, again, mean that you always have to use this. It's not the case that you sort of always need to be watchful for all these forms always. The first thing we did, those first, using the a and the b and the c to factor, always works. So in some sense, there's no reason not to always do that. These special cases are sort of just as you're going through it, more and more of them, probably you'll start to sort of see some of these patterns on your own, and it's just kind of laying them out here. So our idea, right, a, b, c. So a is 1, so that's cool. B is minus 8, and my C is 16. And so what's happening here, right, 16 is going to be 4 squared, and my B term, right, would be the negative version of 2 times 4. So the 4 is really the key number here, right? The 4 is sort of acting as my like D value. So 16 is 4 squared, and then I have the minus version of doubled 4, right? 2 times 4. So we're distinguishing between a squared number and then just doubling the number, squaring it versus multiplying by 2. So in theory, where we should end up so this should be x minus 4 times x minus 4, which you could call x minus 4 quantity squared. Let's kind of try to justify this for a minute. If we do that, let's see if we can kind of work our way through it, right? So C is 16, A is 1, so A times C is 16, multiply to 16, right, our B value is minus 8, we got to add to minus 8. The place where I'm going to skip a couple steps and jump ahead a little bit is not listing all the possibilities here, right? So to a certain extent, we know 4 times 4 is going to be 16. 4 times 4 is 8. We just have to sort of get the numbers, the signs working for us. So negative and negative is going to multiply to positive 16. If I add negative 4 to another negative 4, I'm going to get a bigger negative, negative 8. So negative 4 and negative 4 is 16. Negative 4 plus negative 4 is negative 8. So my pairs are negative 4 and negative 4. So that's going to let me jump, right, using my special case number 1. That's going to let me jump right to x minus 4 times x minus 4, which is what we just said here. You can do the full expansion if you want to sort of double check it. Again, the idea with the special cases is that they're a little bit faster than sort of going through the full process. So just to save time and to illustrate that, I'll leave that off for now. You can, of course, like run through those steps to sort of make sure you believe all this. But probably you believe me. I've got a pretty trusting demeanor, right? Right? Anyway, so that's the P5 review. That's some factoring review. Hope you enjoyed.